So one of the analogies I know that you've used before is that of the butterfly effect. And when we talk about the butterfly effect, those causalities aren't always very clear. So, we're saying that the butterfly is flapping its wings over here and it has these effects over here. We don't necessarily see how it all works. Why is the butterfly effect important to the way that you look at how artificial intelligence can help us predict the future?
So from our vantage point, Ray, it's this. Bangladesh went through an instability. We all know that. Okay. Well, it's one thing to be able to say that the instability happened. Could anyone have predicted it? Yes, we predicted it. Why were we able to predict it? Well, it's because we look at as much as we can. We look at 1,000 different variables on just one country, including climate, which builds up slowly. The effects build up very slowly, and there is socioeconomic, financial, all of that stuff, right? So inflation is going up, and economy is not doing well, and people are generally grossly unhappy, and the climate's not helping at all. And so the tinder keeps building up more and more, and until it gets to a point where a reservation quota becomes an issue, an issue that has been around for decades. So this is a classic multi timescale problem, as we engineers would call it. You have to account for all of those timescales. So okay, so we can predict it. Now here's the point, right? Where does that butterfly effect come in? So the fact that one domino fell, that migrants from Bangladesh are sitting in countries all over the world, right? They go to make a living in Europe or in the Middle East and wherever. And in every country that they go, whether it be France or Italy or wherever, you're a Bangladeshi chef in some restaurant, and now your country just shut down its internet. You can't send money back home. You're going to be unhappy. And so these effects transmit very fast. And suddenly you see there are protests happening in other parts of the world. Okay, so the one thing happening in one place can cause, it's again a slowly building effect in this case, suddenly became an issue when the tinder built up enough and one match could literally create this effect. Something similar happened with Arab Spring, by the way. Before that, young man lit himself up in Egypt, and that fruit seller in Tunisia lit himself up. 18 months ago, there was a fire in Ukraine, right? Remember? And then before that, and so Ukraine being the largest supplier of wheat to the region, well, that means prices would go up. Well, there's Russia. There was a fire in Russia too. It was a really bad year. It was a really dry year. Some of it is attributable to climate change, not all of it. It's also the El Nino cycle. But anyway, then what happens? Well, why didn't Egypt produce its own wheat? Well, they didn't produce a whole lot, but it was also a very bad year because the River Nile was running very low because it's a reservoir. The Lake Victoria, which supplies, was at a historical low. Why is that? Because of historically low rainfall in South Sudan and all of those regions south of Egypt.
So essentially, I'm just trying to contextualize it. So basically, what you're saying is that probably human analysts are not able to sort of pull all of these threads together and come up with something that says this could produce the Arab Spring, but AI can help you do that.
AI can help you recognize that those patterns are being observed. The collection of those patterns are being observed to the point where the butterfly effect can actually kick in. This is when a young man lights himself up and the tinder is really there and it'll just explode.
So the problem we used to have when we were trying to do analysis like this is how to give the right weightings to these various factors,
Yeah, yeah.
right?
And we've struggled with that too, Jim. We've struggled with that too. And what we did that though is we inverted the problem. Instead of us giving the weights, what we did was we let the machine figure out the weights by just giving it what happened and what was observed. And because computation has become so powerful now, that's why neural nets were created and so on, that those weights can now get ascertained in ways that are not just one particular factor to the event at hand, instability, let's say, but it's also combinations of factors. To the point, by the way, that it becomes its own mess because you can't understand why the machine is telling you what it's saying. And then you need that's an art form to actually extract why you're seeing what you're seeing.